In question 6, I write down you've asked every single time I do one of these questions in this whole chapter. Okay, then I'm going to make a list of what letters I have. A cyclist accelerates uniformly from 3 to 11. U is 3, V is 11. During a 6-minute time period, 6-second time period, T equals 6. Find the distance covered, S. Okay, you write down your equations. Phi equals U plus AT. Then you have P squared equals U squared plus 2AS. And then you have S equals UT plus a half AT squared. Now, you have to make a decision on which one to use. You have V, you have U, you don't have A, and you have T. You could find out A from that question. No bother. Okay? In this one, you don't know A and you don't know S. When you don't know two variables, in general, it's unusable for the time being. So we can't use the second one. In the third one, we want to find out what S is. So we don't have S. We have U, we have T, we have a half, we haven't got A, and we have T squared. So bottom line is we can't get the answer straight away. We're going to have to find out what A is. Upon finding out what A is, then we can either use equation 2 or equation 3 to find the answer. Okay? So let's use equation 1. So you're going to choose phi equals U plus AT. Once you do this, you're then going to say 11 equals 3 plus 6A. Bring that over to the other side, and we're going to get 8 equals 6A, and then A equals 4 over 3 meters per second. So remember, the unit of acceleration is how many meters per second squared. Unit of acceleration is ms to the minus 2, or m/s squared. Okay. Now, once you've done that, you found out what your A value is. You're then going to try and use your next formula. Either formula will get you the answer. So I'm going to use the one that S is already isolated on. See the way S is isolated already? It makes sense to use that one. So S equals UT plus a half AT squared. Therefore S is going to be U, which is 3, multiplied by T, which is 6, plus a half A, which we found is 4 over 3, and then we've got to get T squared, so that's going to be 6 squared. I'm going to obviously use the calculator for that. So 3 times 6 plus a half AT squared, 4 over 3, and then, yeah, most of you guys already know how to use this pretty good, so then 6 squared. 42. Okay, so the distance covered is 42. I keep taking one of these, makes it faster. Okay. So 42 meters it is. Now, actually, as it oddly turns out, lads, right, I'm so used to using the 3Ds, right? It's actually the one time, remember the one equation I never use? It's like that actually would have got you the answer straight away. Now that I think about it, so look, I'm going to show you a different way. That was 2 equations, no bother. I only ever use 3 equations, but look, if you really wanted, what you could have done was use the, I never think about using this one because I've never used it to answer an exam question, so you could have done S equals U plus phi all over 2 times T, and this time it would have been 3 plus 11 over 2 times 6, and that would you got 14 over 2, which is 7 times 6, 42. Both answers very quick anyway, right? So that's another way of doing the same question. Okay, folks. Any questions thus far? Yes. Number 8. A train slows down. Keyword about slow down. What will that mean automatically? Acceleration is negative. It's technically a deceleration. Okay, always treat reduction in speed with a negative number for acceleration. From 70 down to 50, no bother, over 8 seconds. And what it goes is find the deceleration and distance covered. Well, I suppose if we want to find the deceleration first, it's going to be phi equals u plus at, because you have 1, 2, you have 3 out of the 4 pieces of information. That's easy, okay? So then you're going to get 50 equals 70 plus 8a. Then bring it over to the other side, you're going to get minus 20 equals 8a. A is going to equal minus 2.5 meters per second squared. Right, handy enough. Now, you have to find the distance covered. Distance covered, we could use any one of the formulas we want. I'll probably still use ut plus a half at squared. Sorry, just take a seat. Okay, so s equals ut plus a half at squared, so that's going to be 70 times 8 plus a half. A is minus 2.5, and then t squared is 8 squared. Going to put all of that into the calculator once, and what you should get is 480. So s equals 480 meters. Okay. So that's what we've done thus far. Okay. Okay. So the next part then. So part 1 there, and that's part A there as well. Okay, guys. So that's our first part of the question. Okay, that's A and S. Now, if the train continues to decelerate at the same uniform rate, how much further will it be able to travel before it comes to rest? So, how much further is the question at the moment? Okay. So you've already travelled 480 meters. And then you can have 480 meters, and A is minus 2.5. Can anybody in the class suggest a method for doing this? 2 different methods. Can anybody? So guys, what you're doing is basically you can have 2 different systems for getting this question. The first system is the acceleration is the same no matter what, because it continues to decelerate. Next piece of information is how long before it comes to rest. Phi equals 0. Now I have 2 ways of doing this. I could start off at my initial value of 70, okay, and what I can do then is I can find the S value, and then whatever that S value is, then take away 480, because that 480 is included, okay, because you started off at 70 in the last question. The other way I could do it was start off at 50, and then find out what the S value is, and that will tell me how much further I went. So both questions will give you the same value. Let's see if that's the case. Now, in this question, I don't have time. I can find time, but I actually can skip that altogether and just use phi squared equals u squared plus 2as. Okay? So then what I can get here is 0 squared equals 70 squared plus 2 times minus 2.5 is minus 5, minus 5s, and then it's going to bring that over to your side. Minus 4,900 equals minus 5s. 4,900 divided by 5. Too early in the morning for that. So 980. S equals 980. Now is 980 meters the answer for that one? No, because you have to take away your initial 480, and what you find there is 500 meters extra. Okay. The other way to do that would have been to do the same equation, and you would have got 0 squared equals 50 squared, once again minus 5s, and then you would have got minus 2,500 equals minus 5s. and then divide it down, and that's 500 meters equals S. So you could get the 500 directly or in a two-step process, depending on what step type of values you used at the start. Okay? What we have here is P and Q are points 162 meters apart. Okay, so there's P and Q, and they're 162 meters apart. Okay, a body leaves P with initial speed 5 and travels towards Q at a uniform acceleration of, so we're going to U vast this. So U equals 5, V equals A equals 3, S. At the same instant, another body leaves Q and travels towards P. So there's another U vast system over here, and it's traveling at initial speed of 7, a uniform acceleration of 2. After how many seconds do they meet, and what then is the speed of each body? Okay, guys. So guys, what we're looking at here is we're looking at two different bodies or vehicles coming towards each other, and then they meet somewhere in the middle. Can anybody tell me which side of the middle will it be? We don't really know, do we? It's sort of 50-50. This one starts off faster. Oh, sorry. This one, the 7 starts off faster, but eventually the P will go faster after, I don't know, after 1 second, isn't it? Oh, sorry, after 2 seconds, this one will be on 11, because 5 times 2 times the acceleration is 11, and this one will be also 11 after 2 seconds. So we're just take a guess. It's somewhere in the middle, okay, or either side of the middle. It doesn't matter. Let S1 be the distance from P, and S2 be the distance from Q. What can we say about S1 plus S2? Sorry? Equals 162 meters. Okay. What can we say about the times? T1 and T2. T1 will have to equal T2. Why? Because the keyword of at the same instant. The same instant means they're both active for the same amount of time. So both call them T and call that one T there. Okay? Now that that's done, we have U, we have A, we want to use S. So what formula do you think is the correct choice? If I write down the 3 formulas I always use, what do you think is the correct choice? Sorry, S equals? U plus V over T. No. S equals U plus V. I'll tell you why I won't use V, okay? Now, there's a good logic in there, okay, because you have the right amount. The thing is, see V1 and V2, you're not guaranteed that they're equal to each other. Yeah. So you're introducing a new variable into the equation. So V, in this case, counts for 2 different variables, while T is the same variable twice. Yeah. So what I suggest we use is S equals UT plus a half AT squared. We find out what S1 is individually, find out what S2 is individually, add them together to get 162. So let's find out if that's what's going to happen. Okay. So what we have here is S1. S1 equals 5T plus a half 3 times T squared. S therefore is 5T plus 1.5 T squared. Okay, and S2 is going to be 7T plus a half of 2. A half of 2 is 1, so 1T squared. Now, use your formula. S1 plus S2 equals 162. So what we're going to get here is what's it going to be? 5T plus 1.5T squared equals, or sorry, plus 7t plus 1t squared equals 162. Move it over the other side. We're going to get 2.5t squared plus 12t minus 162 equals 0. Multiply both sides by, I reckon multiply both sides by 2. So 5t squared plus 24t equals minus 324. Now guys, I'm not going to go through this all. I personally would have a bit of difficulty factorising that without going through a lot of effort. In a test I would have went straight to the minus b formula. Okay, so everybody know the minus b formula? So what's going to happen here is we're going to solve this using the minus b formula. Okay, and once you use the minus b formula, what you're going to get is two answers. You're either going to get t equals 6 or t equals minus 54 over 5. Which one do you not have to use? Time can never be negative, so this here not going to happen. Alright, so the answer is t equals 6. Reread the question. I only got the first part. The distance which each travels in this time. Now you have to find the distance that each one travels. Okay? So, the distance that each one travels. Okay? So you gotta go back to your S1 and S2 formulas. So, that's your S1 and S2 formulas. Okay? So, what we gotta do is go to your S1 and S2 formulas. You can see them here. S1 and S2. So what you're going to do is you're going to replace t with 6. So 5 times 6 plus 1.5 times 6 squared into the calculator with that. You're going to find out that actually I didn't do it in the notes, so I'll have to do it here myself. So what's that going to be, guys? 30 plus 1.5 times 36. I think it's 84. Make sure. So 30 plus 1.5 times 6 squared, 84. So the first one's 84 meters. If the second one checks out, what size should it be as well? Should also be 84, shouldn't it? Because both of them add up to 106. Oh, sorry, they add up to 162. So it should be 78 if we've done this properly. So 7 times 6 plus 6 squared, and that is in fact 78 meters. So both your distances add up to the correct amount. Okay guys, I'll get you guys to try question 13 before I do it myself. So if you want to try question 13. Alright, so what you can see is they're 400 meters apart. They travel a distance and they meet somewhere in here. I don't know what that is, so I'm going to say that's S1 and the other one here is S2. Now, I write down my information for this one's for X and this one's for Y. And we go U, V, A is 4, S we don't know, T is T, because T1 equals T2. Then we have U equals 7, V we don't know, A equals 2, because it says 2 here. Then it says find the time elapses before they meet. Now, the time that elapses before they meet, it's still going to be S1 plus S2 equals 400. Use S equals UT plus a half AT squared. So you're going to get S1 equals 3T plus a half of 4. And a half of 4 is going to be 2. So 3T plus 2T squared. S2 therefore is going to be 7T plus a half of 1. Oh, sorry, a half of 2, which is 1. So it's going to be 1t squared. Add them together, and what we're going to get is 3t squared plus 10t equals 400. Because 3t plus 7t is 10t, 2t squared plus 1t squared is 3t squared. Move the 400 over to your side. And then we have minus 400 here. This is a reasonably easy one to do. I think it's going to be something like 3t and t And then what I need in the middle is what's it, minus 1200 at the back, and that's going to break into 30 and 40. And it's going to be plus 40 minus 30. So
plus 40 minus 10.
Sorry?
Plus 40 minus 10.
Sorry, yeah. So I have to make 30 from this, so that's going to be 10. And that's going to be 40 plus 40 minus 10. There, right? So then we got t equals 10. And the other answer doesn't matter because it's a negative answer, so you can't have t equals minus 40 over 3. Okay? Find the distance that each one travels. Once you've figured out all this part here, what all you're going to do is just plug in your answers back into the original two equations. The original two equations being here, this one there, and this one here. Okay? So there's your original two equations. So all you have to do here is basically plug them in and plug in t equals 10. So it's going to be 30 plus 200, which is going to be 230. And the next one's going to be 70 plus 10, which is 170 meters. Okay? So for those of you that don't